All right, can you see it?
Yes, ma'am.
Okay, so a blank is a segment ray, line, or plane that's perpendicular to a segment at its midpoint. Which one has the word perpendicular in it?
Um, would it be like a circumcenter?
No. This one is just perpendicular to a segment at its midpoint. So here's a segment that's crooked, and here's its midpoint. And it says, what do you call this thing that comes
Oh,
down?
perpendicular bisector.
Yep. Um, Explain how to draw a circle that's circumscribed about a triangle. What's the center of the circle called? Describe its radius. All right. This is your big keyword for the second question.
Well, the circumcenter is the center of the circle.
Mm-hmm. So if you have a triangle, we looked at this in the book, but
Mm-hmm.
circumscribe means that it touches this is so not a circle, but it touches every vertex.
Oh,
And so then when you draw the circumcenter, very messily, when you draw the circumcenter, it's going to
mm-hmm.
be the center of the circle.
Okay.
That
So,
is on, so you can see it much more clearly, is on page 308. It shows you what that looks like with
okay.
neat circles. All right.
Wait, what was the radius?
The what? I'm sorry.
Ma'am?
What'd you say?
I said what was the radius? Sorry.
Let me get a different color. The radius of a circle goes from the center to the side, right?
Yes, ma'am.
So each of these vertices is touching the side of the circle. So the radius is going to go from the center to the vertex of those. I mean, there's more radius that you can draw in that circle, but as it relates to the triangle, it's going to go from the center to where it touches the circle, which is at the vertex of the triangle. That's why we have that the theorem about the concurrency of perpendicular bisectors. It says that those pink lines I just drew are all the same length. The reason they're all the same length is because they're the radius of that circle.
Okay.
That makes sense?
Yes,
These next three are in your chart, right?
I think so. Because we didn't get all of our chart down.
You did. You should have.
We should. No, I'm missing one.
Altitudes.
Yes, ma'am.
Look on classroom. Should be there too. Let's see. Let me double check. Um, yes. If you look on classroom on the stream
Mm-hmm.
on December the 1st,
Mm-hmm.
it's there. I literally took a picture of the board and put it there so y'all could have it.
Nice.
Yeah. But um, the medians and angle bisectors, what do you call it? Where all the medians come together.
Um, the centroid?
Mm-hmm.
No.
Yep.
Oh, it is? Yeah, okay.
About the angle bisectors.
Oh, I already got those. The number 3, 4, 5.
Oh, I thought you were
No, I was
asking
thinking
us.
6 or 8. Sorry.
Gotcha. All right, let me get to the page again. Get the. Can you see it?
Yes, ma'am.
Okay. So we're using the same picture up at the top, and it says DF and EF are mid segments.
Okay.
DF and EF. Okay. And so number 6, if AB is 72, so 72 on that side, find EF. How is the mid segment related to that side that's 72?
It should be 1/2 of it, right?
Yes.
Right.
So how much is EF?
36.
Yeah. All right. Then if DF is 45,
Oh, it should be 45.
EC, yep. Because remember we did this, we put matching tick marks on all 3 of those pieces. So.
Um,
All right. This number 8 is one of those graph in a convenient way problems. I'm going to tell you what page, so if you want to look back to. Let's see. It talks about it. Sorry. It talks about it more on 298 and 299 if you need to go back after this one. But if you're graphing in a convenient way, which quadrant are you using?
If I'm graphing it what way?
A convenient way. That's how they word it in the book.
The quadrant with all the positives. Quadrant 1.
Yes. All right. We have a triangle with these vertices, 2A, 2B. Yeah, buddy. Okay, just a minute. So you're going to come out an x value of 2. Oh, sorry, I didn't mean to mark through it. An x value of 2A and a y value of 2B.
Mm-hmm.
So just think of it as 2. It's 2 times something. So here's A. This would be 2A, right?
Yes, ma'am.
And then the same on the y. Here's B. So this could be 2B. So where's the point 2A, 2B?
You go over 2
Mm-hmm.
and then go up 2.
Yeah. So there's point, what is it, P? Point Q is 2A0. So what do you do for that one?
Hold on, sorry, I'm trying to write it. Point P is in the middle. Yeah. And then for point Q, it's be 2A0. So on the 2A mark.
Sorry. I missed what you said. He's pushing the chair. What'd you say?
Point Q is on 2A.
Mm-hmm.
And O is in the middle. So it's going to be a right triangle.
And then O is just the origin, right?
Mm-hmm.
So there's your triangle.
Yeah.
How do you find the coordinates of the midpoint S of PQ? So PQ is there. S would be somewhere right around there. How do you find the coordinates of that midpoint?
It'd be 1A, 1B.
No,
No.
it's got to be the midpoint of PQ. So it's got to be on that right side over there where I drew the dot.
Yeah. Oh,
1A, 1B would be about here.
2A, 1B.
Yes. And then the midpoint T of QO. Oh, sorry, I didn't label this. This is point O down here. QO is the bottom. And it's saying the midpoint T. What are the coordinates of point T?
It'd be 1A, 2B. Nope. No. 1A, 0.
Mm-hmm. And then the very last part there, show that ST is parallel to PO. So we have points S and T now. Didn't make that. Here's PO. How can we show that they're parallel? What says that things are parallel? What about them?
Well, the O and P and TS are parallel because they really look parallel.
Look it. But remember way back when you had coordinates and the question would say, like, are these lines parallel, perpendicular, or neither? What did you have to do to find out?
Mid-segment theorem?
No. Older than that. You had to do the slope.
Yeah.
If things are parallel, what do you know about their slope?
That their slope is the same.
You got it. So if you can show that the slope of those two lines is the same, then you know for sure they're parallel. Not just they look parallel, but they really are. So the blue and the green there, those coordinates, that will give you the slope of ST. How do you find slope? What's the equation?
Y1 minus Y2, X1 minus X2.
You got it. So for this green and blue, how would you plug them in?
It'd be 2B minus 0 and then over 2A minus 0.
No.
2B over 2A, which narrows out to...
Hang on. You're using different coordinates, I think. Are you doing line PO?
Yes, ma'am.
Oh, okay. I was looking at ST. We were.
Oh, my bad. Sorry.
You're okay. You need that slope too. I just wasn't there with you. Sorry. Okay. So what'd you say? So I can make sure you put it in correctly.
I got 1.
You got 1?
Yes, ma'am.
Let's see. 2B minus 0. 2A minus 0. So minus 0 doesn't really matter. 2B over 2A. The 2's cancel out. But what are you left with?
OBA.
Mm-hmm. B over A. So that's the slope of PO.
Mm-hmm.
Oh. What's the slope of ST?
Let's do 2A minus. Oh, no, my bad. 1B minus 0
Mm-hmm.
all over 2A minus 1A
Yes.
equals 1B 1A equals BA.
Mm-hmm. B over A. So that's the slope of ST. So ST is B over A. PO is B over A. So what do you know about those two lines?
They're not perpendicular. I mean, they're going to be perpendicular
No.
because.
What'd you tell me about
Oh, yeah,
parallel lines?
my bad. I did something wrong.
No, you got B over A, right?
I put B times A
Oh,
by
gotcha.
accident, so that kind of threw me off. No, but it is parallel.
Correct. Because they have the same slope, makes them parallel. Sorry. It's all gone, bud. That was a lot of steps, but did those steps make sense for number 8?
Yes, ma'am.
Yeah. Okay. Let me see if Christian's got something. We'll come back. Christian, do you have a question right now?
No, not right now. I'm good for now.
Okay. Sorry. All right, Braden, do you have another question?
It was just that for right now. Thank you, though.
Okay. Well, I'm gonna get something to drink because I'm choking on something, but I'm still here. I'm just gonna mute it for a minute. Okay, good. Evan asks if you could go ahead and post his. You have to go to tutoring in about 20 minutes, and I want to make sure I got them all right before I go. Sorry, I didn't hear all of that. Can you repeat?
Mom! Mom!
Did y'all lose power at all?
No, we didn't. We had our power. It flickered a couple of times, but it stayed on. But some of our neighbors in the same neighborhood lost theirs.
Yeah. Sorry, I'm changing location because my sister's in the room and she's talking. So,
Miss Luke didn't have power till about 11 o'clock last night.
dang.
She
We
lives
didn't-
close to me, but
We lost all power for 10 hours.
Hmm.
Which, and it was terrible because our whole neighborhood lost power because there's a underground wire that connects to an above ground wire, and that connection was fried.
Oh, gotcha.
And so our whole neighborhood lost power, so we all went to using cell service. So the cell service was terrible.
That's no good.
Yeah.
We went to the store, and like Walmart had to throw out all of their meat, all their eggs, all their milk, all of that. They had to throw it out.
Mm-hmm. Have you seen the comedian about Georgia and snowstorms?
I've heard some things like that, but I don't know if I've heard that one in particular.
So this one guy, it shows like the flurries coming, and he looks out the window and he goes, "I need to go to the store." And then so like he runs out of his house, gets in the car, and it shows him go to the store. And he's at the store and he's like, "I need all of the milk." And so he just starts like shoveling gallons and gallons of milk. And then he runs over and grabs a bunch of bread. And then it like cuts out. And the next scene you see is him sitting down in the snow eating milk or drinking milk, a gallon of milk, and stuffing bread in his mouth.
That's pretty funny. Yeah, I guess that was probably the issue on Friday. I had to go grocery shopping Friday, but it was a little bit rough.
For number 11,
Mm-hmm.
is that going to be like the same? Would it be 5 or would it be 6x minus 5?
To set it up to solve it, you mean?
Or, yeah, like how do you solve that one?
If you're trying to find AB and you have a perpendicular bisector, let me get it on the screen so you can see what pieces I'm talking about.
All right.
This is from the perpendicular bisector theorem. And come on. Come on. Okay, so AB is this piece right here.
Mm-hmm.
And the perpendicular bisectors theorem, this one says BD is perpendicular. So if it says, if there's a point on the bisector, like point B is on the bisector, from that point to each end point is going to be congruent. So once you know X, if you found X earlier, then you use that same X and
And plug it in.
the left side is going to be the same as the right. So just plug in what you found for X.
Okay, thank you.
If you tell me what you got, I'll tell you if it was right.
All right. $25.
You got it.
Thank you. Can you have me on number 12 too? 12 and 13.
Let's see. What is an incenter?
An inset is the point of concurrency of the angle bisectors of a triangle.
Fancy talking. Yes. So come on. Okay. So at the incenter. Oh, so sorry. At the point of concurrency for angle bisectors, there's a theorem for the concurrency of angle bisectors. And it says from that point, so like at point D here, from that point to each side of the triangle, so the blue lines, if they're going to the sides at a right angle, like those are, then they're going to be congruent. So all the little blue lines are congruent because that's measuring the distance from the incenter to the side of the triangle.
Oh, so it's just 5.
Number 12 is just 5.
Oh, that's easy. And then X. X is going to be 5 again, right? No.
You got to figure this one out. This one, you don't know any of the blue lines. So you got to figure out, if you can figure out one of the blue lengths, all of them will be the same because the distance from D to the side is always the same.
20?
No. So you have to figure it out, but you have to use that 20 and that 25 to figure it out. Where that 20 and 25 is, that little triangle CDE.
This one?
What kind of triangle is that?
Right triangle.
I'm going to draw it over here so I can draw it bigger. Here's 20. Here's 25. And if we can find that other side of it, then we would know one of the blue lengths, right?
This one.
Okay, so how can we find that missing side?
Subtract 25 from 20.
No. If you have a right triangle, how do you find the missing side?
I don't know. I don't remember.
Yes, you do.
Um,
Look in the box right above that question. What did they do?
Pythagorean theorem.
Yeah. So, how would you set up Pythagorean theorem to solve for x?
I absolutely have no idea.
All right. You put the longest side by itself on one side and you square it. So 25 squared. You know it's the longest side because it's always across from the right angle, okay?
Mm-hmm.
So 25 squared is going to equal 20 squared plus what?
X.
X what?
X. X squared.
There you go. All right. Oh, hang on one second, Brayden.
Yes.
So then you solve this. 25 squared is how much?
25 squared is 625.
What's 20 squared?
400.
Plus x squared. What do you do next?
Subtract from each side.
So you get 225. Then what?
225 equals x squared divided by x, or divide. You know what I'm saying?
Not divide.
No.
To make it just x, what do you have to do?
Divide or multiply x out. Or, I don't know.
You do know.
I seriously don't know.
You take the square root.
Oh yeah.
While you're doing that, hold that thought 1 second, okay?
Mhm.
Sorry, Braden. I had to tell him something real quick.
No, you're all good.
Okay. So what'd you get?
You got 15.
15 is correct. Good. Sorry, my husband was leaving for work and had to tell him something real quick. So, other questions? Yes, no, maybe.
I'm good for now.
Yeah. Oh, I'm about to post it in Classroom, but number 27, don't do that one. We're gonna leave out the indirect proof part of the chapter since we didn't get to meet on Monday.
Okay.
So, number 27 is the only question about that in the review. So just leave off number 27. And I took that part off the test also.
Awesome.
Okay.
Yeah.
And if y'all didn't watch the videos from the weekend, I would recommend watching them just to kind of make sure you understand the 5.6 stuff, the hinge theorem. It's a really pretty simple concept, but if you just try to read it, it might be confusing. So the guy does a pretty good job explaining how it works. I explained it to my first and second period, but third period didn't get to hear it. So all of y'all can benefit from the video.
Yeah. I'm about to head out. Having fun.
Okay. See you tomorrow. Don't forget, update your spiral.
Got it. Is it a test tomorrow?
It is. Yes.
So we're turning in our spiral.
Correct.
Sweet.
Oh no, did he fall down?
Father.
You want me to get him?
Mom. Mom. A fall.
He's gonna fall again. All right, I'm gonna mute it. If you have a question, I'm still here, but so you don't have to hear Cruz playing with his Ninja Turtle.
Okay. Okay, yeah, I do need help on number 14 and 15, if you don't mind.
Okie dokie, let me get them. Braden, don't doubt yourself. When you start doubting yourself, you're gonna mess up. So don't doubt yourself.
Oh, wait. Wait a minute. That's
What?
I'm just thinking that's mid-segment there. Is there a certain two coordinates I have to choose, or because I know I don't use all three.
The way that I am sure which one is to graph it, and then you can kind of tell. Do you remember when I graphed something on the board and I was saying you can kind of tell which one is more likely to be the right one?
Yes, ma'am.
Kind of, sort of. So if you graph it, which this is going to be messy because let me just show graph paper and then you won't see the coordinates, but you'll see the graph paper. That'd be wiser. Hang on one second. I'm getting a picture of a coordinate plane.
Mom.
Yeah, bud.
I saw Batman.
You found Batman?
Yeah.
Good
Mom.
job.
Mom.
Yeah, bud.
It's
There's a lot of hero work going on over here. We got Batman and Ninja Turtles. That's his helper, not Robin. Can't think of her name. What's the girl that helps Batman? Is it Batwoman?
Batgirl or some Bat.
Batgirl?
Mom,
I don't know.
Mom,
What, bud?
eat that.
Thank you. You want me to take it apart?
Yeah.
There you go. Okay, so the coordinates -4, 0. 1, 2, 3, 4.
Thank you.
Welcome. 2, 2. And 2, -2. All right, I graphed it. I'm going to connect them. So if you do that, if you can draw straight lines, it's kind of easy now to see that this one that follows along the axis, that's the one you're going to want to look at, right?
So I'm thinking your midpoint's just gonna be 0, 0.
It is 0, 0, but what's it called? Not midpoint.
Centroid.
There you go. And the reason it is, just so is not just because it looks like it. The whole length of that median there, this whole middle part that I darkened, is 1, 2, 3, 4, 5, 6 units long. And so 2/3 of 6.
It's 3.
2/3 of
Just
6.
kidding, 2.
Yeah, is 4.
I was just making sure you're on.
Okay. I'm sure I'm awake.
Yeah.
So 2/3 of it from the vertex to the centroid is 4. This little piece would be 2. That's why 0, 0s are centroid.
Okay.
Okay, so if it was like over here somewhere and you had to kind of actually compute it to get it, you need to know the right method, not just because it looks like it, you know?
Yes, ma'am.
Okay. Let's see, number, what's the other one? 15. All right, I'm gonna get rid of this and I'll graph 15 and you can see which one looks like the right one to use.
Okay.
Let's see. -6, 2, 1, 2, 3, 4, 5, 6, 2. And 2, -2, 6. 2, 4. Is that the right point? Let's see. -6, 2, -2, 6, 2, 4. Okay. This one is not quite as straightforward.
I'm guessing your midpoint's going to be -2, 4.
That's correct. Do you have a method to your madness, or are you just looking what looks like it might be right?
Well, I was kind of thinking like the line from S down. I know it's a small line, but still it kind of could be the whole bisector, but also it kind of just looks like it would be there.
The median would be there. Be sure, if you're going to use that one, to be sure that you're using the right part, like to be, because it could, because my ugly graph, technically, I guess it could be here, here, right? Or here.
Yeah.
So to be sure you're using the correct one, where is it supposed to hit? I didn't label my things. RT. Where is it supposed to hit RT? What part of RT? Where does a median hit the side?
At the 2 points. No.
At one point. What do you call this point right here where it's touching that side? Too much red going on. Let me get a different. Huh?
midpoint.
Yeah. So be sure that that is the midpoint before you assume. So to get the midpoint, you would use the midpoint formula, which I know you're thinking, why am I going to go through all that? Because I know it's the right answer. But I want you to be sure, and it's not that much work. And heads up, on the exam, you're going to have to know how to find midpoint using the formula. So practice, why not, right?
Yeah.
Um, what goes on the top of the first equation here? Sorry, the first fraction.
X2 plus X1.
Mm-hmm. So with these numbers, what would you have?
2 plus -6.
Got it. And then on the second one,
4 plus 2.
yep. So because of that, it's -2, 3, right? That is the midpoint. And that is where we're thinking it's going to hit. So you're good. So
Awesome.
when you're drawing a median, it's got to hit the midpoint so that your median itself, you can go 2/3 of the way down to find your centroid.
Mom,
Mm-hmm.
yeah.
Hit your head.
Yeah.
I'm sorry.
Oh. Wow.
Other questions right now? Or are you just looking ahead at the next ones?
I'm trying to think of what is 2 or I'm on 16.
Okay. Tell me if you need help.
All right.
All right, Braden, it's getting close to 10:30. Do you have one or two more you want to look at together, or are there any that you want to check to make sure we're on the right track?
Oh, I think I'm good actually. Yeah, I got the rest of them.
Okay.
Thank you.
You're welcome. Like I put around noon or so, I'm going to send out the answers so that you can check all of them. And if you miss something and you can't figure out what happened, you can email me after that.
Yes, sir. Thank you.
You're welcome. Have a good day.
You too.
Thanks.